Dear children, it is a continuation of the chapter Real Numbers. Now let us factorize some composite numbers. Let us express the composite numbers as a product of prime factors. Here there are some numbers. Now let us take the first number. What is the first number? 455. Let us take this number and express it as a product of prime factors. So you take 455. Here the given number is 455 and the first prime number is 2. Check whether it is divisible by 2 or not. You know that all even numbers are divisible by 2. All even numbers are divisible by 2. Now you check whether it is even number or odd number. You know that in the unit place there is 5. If the unit place is odd, then the whole number is odd number. If the unit digit is even, then the whole number is even number. To become the even number, the unit digit must be 0 or 2 or 4 or 6 or 8. To become the even number, what must be the unit digit? The unit digit must be 0 or 2 or 4 or 6 or 8. Here there is no 0, 2, 4, 6, 8. What is there? 5 is there. So this whole number is, the 455 is not even number. So it is not divisible by 2. That is the divisibility test by 2. Then you take the next prime number 3. Now you check this 455 is divisible by 3 or not. What is the divisibility test by 3? Here you find the sum of all the digits. First digit is 4, write 4. Second digit is here, the digit in the 10th place is 5. And the digit in the unit place is 5 plus 5. Then what is the sum of these 3? That is 4 plus 5 becomes 9. 9 plus 5 is 14. 14 is not in the table 3, means 14 is not divisible by 3. Therefore, this 455 is also not divisible by 3. So, you can't divide it by 3, means 3 is not a factor of this for 455. So, you clear that 2 and 3 are not the prime factors of 455. They are not the factors of 455. Next, you try it by the next prime number 5. After 2 and 3, what is the next prime number? 5. So, before dividing, check whether it is divisible by 5 or not. Means, check whether the 5 is factor of 455 or not. What is the divisibility test by 5? The unit digit must be 0 or 5. Here, the unit digit is 5. So, you can conclude that 455 is divisible by 5. It means 5 is a factor of 455. Now you can divide 455 by 5. So you write 5 here. Then 4 is smaller than 5. So then you must take 45. You know that 5 9s are 45. 5 9s are 45. Now what is remaining in the unit place? There is 5. Then 5 1s are 5. Now you got 91. 91 into 5 is 455. Again you take 91, try to divide by 5. Check whether it is divisible by 5 or not. Check the unit digit. What is the unit digit? Unit digit is 1. Already you know that if there is 0 or 5, 0 or 5 in the unit place, then only it is divisible by 5. But here, what is the unit digit? The unit digit is 1. So it is not divisible by 5. Means 5 is not a factor of 91. Then you try it by 7. The next prime number is 7. After 5, which is the next prime number 7. Now you check whether it is divisible by 7 or not. Then what is the divisibility test by 7? Or directly you know that 13 sevens are 91. Directly you can take 7. If you know the table correctly, you can conclude that 91 is divisible by 7 because 13 sevens are 91. Then you know that 7 ones are 7. 9 is there, and below 9, 7, which is in the table 7, 7 ones are 7. Then what is remaining here? 9 minus 7. Here 9 is there, and 7 ones are 7. 9 minus 7 is 2. So here what is remaining? 2. So it becomes 21. 21. Then 7 threes are 21. Here 21 is there. 7 threes are 21. Next, 13 itself is a prime number. Then directly you can write 13 ones are 13. Then the factors of 455 are 5, 7 and 13. Then you write 455 is equals to 5 into 7 into 13. Here 7 13s are 91, and divisibility test by 7 also there. What is the divisibility test? Here take the unit digit and double it. That is 1 into 2, 2. Next you take the remaining truncated number. What is remaining? 9. 9 minus 7. 9 minus 2. Not 7. 9 minus 2 is equals to what? 7. 7 is divisible by 7. Then you can conclude this 91 is also divisible by 7. Or otherwise directly if you know the table, you can divide it. So what are the factors of 455? 455 is equals to 5 into 7 into 13. This is the prime factorization of 455. Here we expressed 455 as a product of primes 5, 7 and 13. Then you take the next composite number 420. Take 420. Take the number, and here you know that 0 is in the unit place. Then you can conclude it is divisible by 2. Then you divide it by 2, and the first you take 4. 4 is in the table 2. 2 2s are 4. Then what is there? 2. 2 1s are 2. Then 2 zeros are 0. Again here 0 is in the unit place. Again it is divisible by 2. Then you divide it by 2. 2 1s are, and 1 is there smaller than 2. So you write it as 0. Then 10. 2 5s are 10. Sometime you are doing the mistake that 210 means 2, 1 you are writing. Next directly you will write 5, but it is wrong because you know that 15 2s are 30. But here 210 means 2 into 105 is to 10. Next here you got 105, 105. Then you check it by 3. What is the divisibility test? Add all the digits. 1 plus 0 plus 5, which is equals to 6. 6 is in the table 3, means 6 is divisible by 3. Then you can conclude that it is divisible by 3. It is means 105 is also divisible by 3. Then you divide it by 3. Then you take 10. 1 is smaller than 3. Then you must take 10. 10 means 10 is not in the table 3, but its previous number 9 is there. 3 3s are 9. Then 10 minus 9. 3 3s are 9 is there. 10 minus 9 is 1. 1 5 means it becomes 15. 15 means 3 5s are 15. Then you got 35. Again you try to divide by 3. You know that 5 plus 3. 3 plus 5 is equals to 8. 8 is not in the table 3, means it is not divisible by 3. Therefore 35 is also not divisible by 3. So you can't divide it by 3. Then you take the next prime number 5. It is divisible by 5 because 5 is in the unit place. Then you divide it by 5. You know that 5 7s are 35. Then 7 is prime number, 7 ones are. Then 420 is equals to what? 420 is equals to 2 times 2's are there. You write 2 into 2. Next 3 into 5 into 7. Now you write here 2 came 2 times. 2 into 2 is there. So 2 power 2 means 2 times 2 comes here. Next you write 3. Then you write into 5. Next into 7. So 2 into 2 is there. You can write in the form of power, that is 2 power 2. So this is the prime factorization of 420. 420 is equals to what? 2 power 2 into 3 into 5 into 7. Now let us take the bigger number 32,760. So you take the number 32,760. Now first prime number is 2. Try to divide it by 2. Here 0 is in the unit place. So you can conclude 2 is a factor of 32,760. Means 32,760 is divisible by 2. Then you write 2 and divide. Then you take the first digit 3. You know that 3 is not in the table 2. Its previous number 2 is there. 2 ones are 2. Next, what is remaining here? 3 minus 2. 2 ones are 2 means 3 minus 2. 1 is remaining. 1 and 2. That is the number becomes 12. And 2 6 are 12. Then 7 you take. 7 is not in the table 2. 2 3s are 6 is there. 2 3s are 6. Again what is remaining? 7 minus 6, 1. 1 6 means it becomes 16. 16 means 2 8s are 16. Then 2 zeros are 0. Again you got the unit digit 0 means it is divisible by 2 again. So you divide it by 2. Then 1, first digit is 1. It is smaller than 2. So you take 16 together. So 2 8s are 16. Again 3 is there. 3 is not in the table 2. So 2 1s are 2. Then 1 is remaining. 1 8 means 18. 2 9s are 18. Then 2 zeros are. Again 0 is in the unit place. Try to divide it by 2. Because it is divisible by 2. So you write 2. 8 is there. You know that 2 4s are 8. Then here 1 means 1 is smaller than 2. Then you write 0. 2 zeros are 0. Then what is remaining here? 1 9 means 19. 2 9s are 18. Then what is remaining? 1 0 10. That is 2 5s are 10. Next, you got the unit digit 5. It is an odd number. So, 2 is not a factor of 4095. Means it is not divisible by 2. Then you try to divide it by 3 if it is possible. Check whether it is divisible by 3 or not. Add the digits 4 plus 0 plus 9 plus 5 and 4 plus 0 4, 4 plus 9 13, 13 plus 5 18. Means 18 is divisible by 3 means this 4095 is also divisible by 3. Then you write 3 and divide it by 3. Here first digit is 4. 4 is not in the table 3 but 3 ones are 3 is there. So you write ones are, what is remaining here? 1. 1 0 it becomes 10. 10 means 10 is not in the table 3. 3 3s are 9 is there. Again 1 is remaining here. 10 minus 9, 1. 19. 19 is not in the table 3. So its previous number 18 is there. So 3, 6 are 18. 19 minus 18 is 1, 1, 5. Last you will get 15. 15 is in the table 3 means 3 5s are 15. Then again try to divide it by 3. 1365 you got. Check whether it is divisible by 3 or not. Means find the sum of all the digits. 1 plus 3 plus 6 plus 5. 1 plus 3 4. 4 plus 6 10. 10 plus 5 15. 15 is divisible by 3. Therefore, the number 1365 is also divisible by 3. So, you write 3. Then 1 is smaller than 3. Then you take 13. 13 is not in the table 3. Its previous number 12 is there. 3 4s are 12. Next, what is remaining? 1 and 6. 16 is there. Then 16 is not there. Its previous number 15 is there. 3 5s are 15. Again 1 is remaining. 1 5 15 it becomes 3 5s. You got 455. Check whether it is in the table 3 or not. Find the sum. 4 plus 5 plus 5. You will get 5 plus 5 10. 10 plus 4 14. So you got 14. 14 is not in the table 3 means 3 is not a factor of 14. Therefore 455 is also not divisible by 3. 455 is not in the table 3 means 3 is not a factor of 455. Then next you try it by 5. You know that the unit digit is 5. Therefore this 455 is divisible by 5. Then you divide it by 5. Then take 4. 4 is smaller than 5. Take 45. 5 9s are 45. Then 5 ones are. Next, you know that the unit digit is 1 means it is not divisible by 5. Then you try it by 7. You know that 13 7s are 91. Then you take 7 13s are. 13 itself is a prime number. Then you can write 13 into 1. In this way, you got the factor 32,760 is equals to 2 into 2 into 2. 3 times 2 you got. You write 2 into 2 into 2 into. Next, 2 times 3. Write 3 into 3. Then 5. Next 7. Then 30. You write 7 into 13. Count the factors. 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. So, got all the factors. Now, if it is possible, express in the form of power. Here, you got 3 times 2. So you can write it as 2 power 3 into 2 times 3. It is 3 square into, then you write 5 into 7 into 13. So these are the prime factorization of the 32,760. So you expressed 32,760 as a product of prime factors. Now let us factorize 1771. So you write 1771. Try to divide it by 2. Is it divisible by 2? Here you verify the unit digit. What is the unit digit? 1. So it is not a even number, it is odd number. Then what you can conclude? It is not divisible by 2. As the unit digit is not 0, 2, 4, 6, 8. It is not a even number, it is odd number. So it is not divisible by 2. Next you try it by 3. Then how will you check whether it is divisible by 3 or not? Add all the digits. 1 plus 7 plus 7 plus 1 equals, it becomes 1 plus 7, 8, 8 plus 7, 15, 15 plus 1, 16. So you got the sum 16. And 16 is not divisible by 3. Therefore this 1771 is also not divisible by 3, means it is not in the table 3. Next you try it by 5. Is it divisible by 5? Here observe the unit digit. Unit digit is not 0 or 5. So it is not divisible by 5. Next you try it by 7. Then how will you check? Take the unit digit and double it. 1 into 2, 2. Then you take the remaining truncated number 177. 177 minus 2. That is 7 minus 2 is 5. You got 175. Again you take the 5. Double it. 5 into 2 equals 10. And take the remaining truncated number 17. 17 minus 10 equals 7. Then you got 7, which is in the table 7. Then you can conclude this whole 1771 is divisible by 7. How you can say that 1771 is divisible by 7? Here take the unit digit, double it, you got 2. 1 2 is 2. Then you subtract that 2 by 177, you got 175. Again you take the unit digit and double it, you got 10. 5 2 is 10. Then take the remaining truncated number 17 minus this 10, you got finally 7, which is in the table 7. Therefore you can conclude that this 1771 is divisible by 7, means it is in the table 7. So you take 7. Then 1 is smaller than 7. Then you take 17. And 17 is not in the table 7, then its previous number is 14, that is 7 2s are 14, and what is remaining? 3. 3, 7 becomes 37. How you got 3? Here 7 2s are 14, and from 17 we have to subtract 14, that is 17 minus 14 is 3. So here 3 is remaining. 3 7 you will get 37, and 37 is not in the table 7, its previous number 36 is also not there, and 35 is there. 7 5 is 35. Again 37 minus 35 means 2 is remaining. 37 minus 35 means 2 is remaining. 2 1 means 21. Then you can write 7 3 is 21. Again try to divide by 7 if it is possible. First try to find out whether it is divisible by 7 or not. Again follow the same tricks. 3 2s are 6. Take 25. 25 minus 6. What you got? 19. 19 is not divisible by 7. Therefore, this whole number 253 is also not divisible by 7. Then you try to divide it by 11. And here, what is the divisibility test by 11? Find the sum of the alternate digits. 2 plus 3 is equals to 5, and 5 is there. 5 minus 5 is equals to 0. Then you can conclude it is divisible by 11. Means sum of the alternate digits we have to find out, and the difference we have to find out. After finding the sum of the alternate digits, we have to find the difference of the sum of the alternate digits. It must be 0. So you can conclude it is divisible by 11. Then you take 11 and 25 is there. 11 2s are 22. Because 25 is not in the table 11, 24 is also not there, 23 also not there, 22 is there. So 11 2s are 22. 25 minus 22 means what is remaining? 3 is remaining. 33 you got here. Means 11 3s are. You got 23, and 23 itself is a prime number. It is not in any other table. Then you can write 23 1s are 23. Therefore you can write 1771 is equals to 7 into 11 into 23. 7 into 11 into 23. Now let us take the next number, next composite number, 8232. You write that number and try to factorize it. 8232. Try to divide it by the first prime number 2. Unit digit is 2. So it is an even number and it is divisible by 2. Take here 2. And first digit is 8. You know that 2 4s are 8. Again 2 is there. 2 1s are 2. Then 3 is there. 3 is not in the table 2. Then 2 1s are 2 is there. And what is remaining here? 1. 2 6s are 12. Next you take the number 4116. It is also divisible by 2 because the unit digit is 6. Therefore you divide it by 2. Write 2 here. The first digit is 4. It is in the table 2. So you know that 2 2s are 4. The next digit is 1. It is smaller than 2. So you write 0 here. Next you take 11. Because 1 is smaller than 2. So you can take 2 zeros are 0. So what is remaining here? 1. 1 and 1 it becomes 11. And you know that 11 is not in the table 2. Its previous number 10 is there. So you write 2 5s are 10. Next 11 minus 10 means 1 is remaining. Then it is 16. 16 is in the table 2. That is 2 8s are 16. Now you got 2058. This is also divisible by 2 because the unit digit is 8. It is a even number. Then you divide it by 2. 2. Here you consider 2. 2 1s are 2. Next 2 zeros are 0. Then 2 2s are 4 you will take. 5 is not in the table 2. Its previous number 4 is there. Therefore you have to take 2 2s are 4. Then you take 8. And here what is remaining? 1. Then it becomes 1 8 18. 2 9s are 18. Then you know that you got the number 1029 is not divisible by 2 because the unit digit is 9 and it is not a even number, it is odd number. So you can't divide it by 2. Then you try to divide it by 3. Check whether it is divisible by 3 or not. Take the digits of 1029, that is 1 plus 0 plus 2 plus 9. Here 1 plus 0 1 plus 2 3 plus 9 12 you will get. 12 is in the table 3. So this whole number 1029 1029 is also in the table 3, means it is divisible by 3. So divide it by 3. 3. Now you take 1. 1 is smaller than 3. So you take the number 10. Then 3 3s are 9 you take, because 10 is not in the table 3. Its previous number 9 is there. Then what is remaining? 10 minus 9, 1. 1, 2, 12 it becomes. 3 4s are 12. Again 9 is remaining here. 3 3s are 9. You got 343. 343. Check whether again it is divisible by 3 or not. Add the digit. 3 plus 4 plus 3, that is 3 plus 4 7, 7 plus 3 10. 10 you got. 10 is not divisible by 3, though therefore 343 is also not divisible by 3. Then you try it by 5. 5 is not a factor of 343. 343 is not divisible by 5 because the unit digit is 3. To divide by 5, the unit digit must be 0 or 5. Here 3 is there, so it is not divisible by 5. So try to divide it by 7. Then what is the rule? If you take 343, take the unit digit and double it. Double it. 3 2s are 6. Then you take 34 and minus 6. Take the truncated remaining number. And 34 minus 6. You know that 6 is smaller than 4. In that case, take 1 from 3, that becomes 14. 14 minus 6. 14 minus 6 is 8. Here what is remaining? 1 is already taken. 2 is remaining. So you got 28. You know that 28 is divisible by 7. Therefore, this 343 is also divisible by 7. Then you take 7. 3 is smaller than 7. So you take 34. 34 means 34 is not in the table 7. That's previous number. 33, 32, 31, 30, 29. All are not in the table 7. 28 is there. These 7 4s are 28. Then what is remaining? Here 34 minus 28 is 6. 63. The number is 63. 63 means 7 9s are 63. Again you know that 49 is divisible by 7 because 49 is a square of 7. Then you take 7 7s are 7 1s are. So what are the factors of 8232? 2 into 2 into 2 into 3 into 7 into 7 into 7. Then you write 8232. 8232 equals 2 into 2 into 2. 2 into 2 into 2. Next 3 into 7 into 7 into 7. 7 into 7 into 7 equals 2 into 2 into 2. That is 2 power 3 into 3 into 7 into 7 into 7. 7 power 3. So you got the prime factorization of 8232, which is equals to 2 power 3 into 3 into 7 power 3. Now let us take the next number 10,626. So let us factorize 10,626. Here the unit digit is 6, so it is divisible by 2. You divide it by 2. Here 1 is smaller than 2. Therefore you take 10. So 2 5s are 10. Next you take 6. 2 3s are 6. Then you take 2. 2 1s are 2. Then 6. 2 3s are 6. Here you got the unit digit 3. So you know that it is not divisible by 2. Now you try it by 3, whether it is divisible by 3 or not. Add the digit 5 plus 3 plus 1 plus 3. So here 5 plus 3 is 8, 8 plus 1 is 9, 9 plus 3 12. So you know that 12 is divisible by 3, and therefore the number 5313 is also divisible by 3. Then you write 3 here. 3 ones are 3. What is remaining? 5 minus 3, 2, 23. 23 means 3 sevens are 21. 2 is remaining. 2 1. 3 sevens are 21. 3 ones are. Now check whether it is divisible by 3 or not. Find the sum of the digits. 1 plus 7 plus 7 plus 1. Here 1 plus 7 8. 8 plus 7 15. 15 plus 1 16. 16 is not divisible by 3. Therefore this number is not divisible by 3. And check by 5. The unit digit is 1. So you can say that it is not divisible by 5, as the unit digit is not 0 or 5. Next you try it by 7. Write the number 1771. The last unit digit is 1. Double it. 1 into 2, 2. Next take the remaining truncated number 177 minus 2. You will get 171. Again you take this 1 and double it. 1 into 2, 2. Then 17 minus 2, you will get 15. 15 is not divisible by 7. Therefore, the number 1771 is not divisible by 7. Next, you try it by the next prime number 11. And for 11, you can take the sum of the alternate digit. 1771. 1 plus 7, 8. Then 7 plus 1, 8. 8 minus 8, 0 you will get. So you can say that it is divisible by 11. Then you take 11. Then 17 you take. 11 ones are 11. Then 17 minus 11 is 6, 67. 67 means 66 you can get here. 11 6 the 66. And 11 ones are 11. Next you got 161. Now check again by 11, is it divisible by 11 or not. Then the sum of 1 and 1 becomes 2, and 6 minus 2, you will get 4. Now you check by 7. Check whether 1771 is divisible by 7 or not. You take that number 1771. The unit digit is 1. So you double it. 1 into 2, 2. Then you take the remaining truncated number 177 minus 2. You will get 175. Then you take 5. 5 into 2, 10. 17 minus 10, that is 7. And you got 7 means that is in the table 7. So it is this number 1771 is divisible by 7. So you divide it by 7. Next you take 7. Take 17. Now that 7 2s are 14. 3 is remaining. 7 5s are 35. Again 2 is remaining. 7 3s are 21. Then you try it by 7. Again 253 is there. Double it. 3 2s are 6. 25 minus 6 is how much? 19. 19 is not in the table 17. So it is not divisible by 7. The number 253 is not divisible by 7. Then you try to divide it by 11, and verify whether it is divisible by 11 or not. Take the number 253. So find the sum of the alternate digit. 2 plus 3 5, and again 5 is remaining. 5 minus 5 is 0. So you can conclude it is divisible by 11. Then you write 11. 25 is there. 22 is divisible by 11. So you write 11 2s are 22. Again what is remaining? 3. It becomes 33. 11 3s are 33. Then you got 23. You know that 23 itself is a prime number. Then you write 23 1s are 23. So you got the factor 2 into 3 into 7 into 11 into 23. Then you write 10,626 equals 2 into 3 got, next into 7 into 11 into 23. Here the prime factorization of 10,626 is 2 into 3 into 7 into 11 into 23.